Hey folks, Serdar here, and in this episode of Dev with Serdar, we're going to take a look at some of the useful new features in Go 1.21. The first thing I want to highlight that's new in Go is a couple of new built-ins for the language. These are things that are available anywhere without importing packages, and they are min, max, and clear. Let's start with min and max first. Min and max are things that are found in a great many other languages, but they haven't been present in Go natively until now. And the idea is that you could provide a fixed number of arguments to the min or max function at compile time, and then the function will return the largest or smallest value among them. And this will work with any type that supports comparison operators, greater than, less than. For instance, in this example here, I have min and max computations for integers. But I also have min and max computations for strings, because we can compare strings against each other based on lexical sorting. So in the example that I have here, the word caster shows up as being greater than ABBA, and also greater than a blank string. And again, the big takeaway here is that we have a built-in way to do this with any types that support comparisons. We don't need an external package to do it. However, the big downside is that we still have to specify all of the objects that we want to compare at compile time. So we cannot pass a slice, for instance. We cannot get the max of the elements that are present in a slice. It doesn't work that way, at least not yet. Now, one of the other new built-ins we have is specifically for maps and slices, and it's called clear. So if you feed it a slice or map, it will set every element of the slice or map to the 0 value for the data type that's present in that map or slice. So for instance, if it was an integer slice, all of the integers would be set to 0. If it was a string slice, all the strings would be blank strings. Now, you'll notice that when we run this on our string slice, it will say that the string slice still has the length 4. And that's because all the strings in it are now 0 length strings. It just reports as a blank space when we print it. Now, a few of the other big new features in Go 1.21 are available as packages in the standard library. And they're a big hint as to how the language is making better use natively of its new generics features. And two such new packages are called slices and maps. And the slices package lets you perform operations on slices that contain any type. So for instance, the contains operation lets you check if a given element is present in a slice, and it returns a Boolean. And if you wanted to know the index of a given element in a slice, we could use the index function. And by the way, if the element in question is not present, the index that we get back is -1, which is something that we've seen in other languages that have the same behavior. There's another generic operation we can perform, and it's called compact. And this iterates through a slice, and it will replace consecutive instances of the same element with a single instance of that element. So for instance, in the string slice, we have 2 instances of C, and they're compacted into 1 instance. And in the int slice, we have the 2s and the 4s, the runs of 2s and 4s, similarly compacted. There's another operation that we can perform on slices, and that's grow. And what this does is it preemptively allocates slots for future growth with a slice. And again, it can do this regardless of the type. So in this example, we say, I want to allocate at least 6 slots into this slice. And when we do so, it reports back the capacity for that slice is now 16. This is sometimes because the allocation algorithm will give us more than what we ask for, but the idea is that we will get at least as many slots as we request. We also have another package for performing generic operations, and it's the maps package. And as you can guess from the title, it gives us generic operations that we can perform on map structures regardless of what types are stored in them. So for one example, we have clone. This is also available in the slices package, by the way. And what this does is it makes a shallow copy of a map. A shallow copy means the map itself, the map structure, is distinct, but the contents are the same object if you have a non-primitive type stored there, for instance. So as you can see, we've got clone operations for two different kinds of maps. One of them is a string int map, and the other is a string map. So the same operations will work completely interchangeably on both types. So we have one last one here, which is available for both maps and slices, and that's equal. And this does exactly what you think. It compares all the elements of both things fed to it and returns true if they're the same. And again, as long as the map types compare to the same, it doesn't matter what types of maps you're using. And you'll notice that if I try to compare two maps that have different types, the compiler will squawk at me. Now, these are far from the only functions that are available in the maps and slices packages, but the examples I've given here should give you a good idea of what kinds of things you can do. So to sum up, the new min and max built-ins in Go 1.21 let you get the smallest and biggest values from a fixed number of inputs. And these slices and maps packages, now in the standard library for Go 1.21, give us generic operations that we can perform on maps and slices, regardless of what types are stored in them. And these are nice hints as to how generics in the Go language are getting deeper use right in its own standard library. So that's it for now. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.